Assalamualaikum and hi everyone. In this lesson, you are going to learn on how to draw Lewis structure of covalent species with single, double and triple bonds. And later, we will compare the bond length and strength between single, double and triple bonds. Enjoy your learning! Can you spot the difference between the diagram on the left and the one on the right? Yes. The area sharing of electrons in this diagram is represented by dot symbol. So this diagram is so-called Lewis diagram or Lewis dot symbol because we use dot symbol to represent the area of sharing of electrons. Meanwhile, the diagram on the right is called Lewis structure and we use single lines to represent the covalent bonding. So in this video, you are going to learn on how to draw Lewis structure in this format. Do you want to draw Lewis structure for covalent compound? Follow these methods steps by steps. Let's do this together. We are going to draw Lewis structure for this covalent compound CCl4. So for the first step, you have to calculate total number of valence electrons and you have to consider valence electrons for all atoms. So for the carbon has 4 valence electrons. Chlorine has 7 valence electrons, but here we have 4 chlorine atoms, so you have to times 4. And later on, find the overall or total valence electrons. So now we have as much as 32 valence electrons. Second step is draw the skeletal structure of CCl4. In this case, you have to arrange less electronegative atom at center and more electronegative atom at the terminal. Kita akan susun atom yang kurang elektronegatif supaya menjadi central atom, iaitu atom yang berada di tengah, dan more electronegative atom akan berada di hujung, ataupun sebagai terminal atom. So between carbon and chlorine, which one is less electronegative? The answer is carbon. So in that case, you have to put carbon as central atom and the rest of the chlorine atom will be the terminal atoms. In step 3, draw a single bond to connect between central atoms to each terminal atoms. So this one bonding or a single bond represent 2 electrons. Satu single bond mengandungi sebanyak 2 elektron. And then make sure you minus bonding electrons from the total valence electrons. So since here we have 4 terminal atoms, so we have to draw 4 single lines to connect the central atom with the terminal atom. So now this one bonding consists of 2 electrons. So we have used sebanyak 2, 4, 6, 8 elektron. So don't forget to minus bonding electrons from total valence electrons. So yang mana satu bonding electrons, ini adalah bonding electron. So we have 1, 2, 3, 4 pasang bonding pair over here. So 4 pasang bersamaan dengan 4 darab 2, 8 elektron. So 8 elektron telah digunakan untuk kita jadikan sebagai covalent bonding. So since we have used 8 electrons, so remaining electrons will be 32 minus 8, iaitu kita masih ada sebanyak 24 electrons. How many remaining electrons do we have? We have 24 remaining electrons from the previous calculation. In step 4, you have to put the remaining electrons at the terminal atom until they achieve octet. So berapakah elektron untuk mencapai oktet? Maksudnya kita kena ada sebanyak 8 elektron pada setiap terminal atom. So in this case, this chlorine already has 2 electrons from the bonding. So untuk mencapai oktat iaitu 8 elektron, klorin masih perlukan sebanyak 6 elektron. So dari mana kita nak ambil 6 elektron itu? Kita akan ambil daripada these remaining electrons. So now we are going to take another 6 electrons from here dan letakkan di klorin ini. Maka you akan dapat this diagram. Okay. So by doing this, you can check for the terminal atoms chlorine here. So this chlorine now sudah mempunyai sebanyak 2, 4, 6, 8 elektron. So this chlorine sudah pun mencapai oktat. So daripada calculation tadi, 24 minus 6 yang telah diguna pakai pada chlorine ini, so kita masih ada lebihan sebanyak 18 electrons. So let's move to another terminal atom. So this terminal atom juga harus mencapai oktat. So apa kita perlu buat adalah chlorine sudah ada sebanyak 2 elektron. So we need another 6 elektron untuk nak mencapai oktat. So that 6 elektron akan diambil daripada 18 elektron here. So by doing that, now this chlorine sudah pun mencapai oktat 2, 4, 6, 8. Okay, so dari mana kita ambil 6 elektron ini ataupun 3 pasang elektron ini? Kita ambil daripada remaining electrons here. So now, selepas 18 ditolak dengan 6, kita masih ada baki sebanyak 12 elektron. So this chlorine sudah pun mencapai oktat. Move to another chlorine. Sama juga, capai oktat untuk this chlorine. So now dia dah ada 2. Perlukan lagi 6. Ambil daripada mana? Ambil daripada this remaining electrons. Okay, so by doing that, 12 tolak dengan 6, kita masih ada baki sebanyak 6 elektron. So this chlorine now sudah mencapai 2, 4, 6, 8 elektron. Okay, so this chlorine pun sudah mencapai oktat. So for this chlorine as well, okay, nak capai oktat kena ada 8. Again, 2 elektron dah ada. Okay, dia perlukan lagi 6 elektron. So ambil daripada mana? Ambil daripada these remaining electrons. Okay, so by doing this, 6 tolak dengan 6 dan kita ada 0 electrons left. So no more electrons left selepas kita dah distribute remaining electrons ke dalam this Lewis structure. So bila awak check balik ke semua terminal atoms di sini sudah pun mencapai octet stability. Do we have any remaining electrons from the previous calculation? The answer is no. But if yes, you have to put the remaining electrons on the central atom. But in this case, since we have no more remaining electrons, maka this will be our Lewis structure. But before that, you have to check once again. Make sure all terminal atoms and the central atom juga sudah mencapai octet. So for this chlorine, sudah mempunyai sebanyak 2, 4, 6, 8 elektron. Okay, ini pun 8, this one 8, this one pun 8. So all terminal atoms sudah mencapai octet stability. And for the carbon atom here at the center, okay, this carbon has also achieved 2, 4, 6, 8. Okay, that is octet stability. So since all atoms in this structure has achieved octet stability, maka we can say that this is our Lewis structure for CCl4. If central atom is not yet octet, move lone pair from terminal atom to form multiple bonding. Okay, seems that the step 6 here is not related to our CCl4. Okay, maka we can skip this step. Alright, now jom kita lukis Lewis structure for NF3. So first step, macam biasa, calculate total valence electron of all atoms. So we have nitrogen. Nitrogen valence is 5. Fluorine, valence is 7. But we have to times 3 sebab kita ada 3 fluorine di sini. Okay, and from there, you tambahkan, you will get total valence electron 26 electrons. In step 2, draw the skeletal structure of NF3. So between nitrogen and fluorine, identify the less electronegative atom. atom and put the less electronegative atom at the center as the central atom. And the more electronegative atom will be at the terminal. So between N and F, definitely N is less electronegative. So nitrogen will be at the center and the remaining 3 fluorine atoms will be terminal atoms. So this will be the skeletal structure for NF3. In step 3, draw all single bond to connect between terminal and central atoms. So one single bond consists of 2 electrons, and please remember to minus the bonding electrons from total valence electrons. So in this case, from the skeletal structure, we are going to use 3 single bonds to connect between the central atom N with terminal atom F. So ingat, dalam satu bonding ni ada berapa elektron? They have 2 electrons. Okay, so since we have used 6 electrons for the bonding, so remaining electrons will be 26 minus 6, so we have another 20 electrons. In step 4, put remaining electrons at the terminal atom until achieve octet. So how many remaining electrons do we have? Tadi kita ada sebanyak 20 elektron. So let's check for this fluorine atom dahulu. Fluorine has 2 electrons already. So nak mencapai octet, which is 8, fluorine needs another 6 electrons. So dari mana nak ambil 6 elektron itu? Kita akan ambil daripada these 20 remaining electrons. So by doing that, kita akan susun 6 dots pada fluorine menunjukkan bahawa fluorine dah ada 6 elektron. Okay, padanya. So 20 tolak dengan 6 dots tadi. So kita akan ada baki sebanyak 14 electrons. So now check the stability of this fluorine. Now this fluorine has 2, 4, 6, 8 electron. So this fluorine sudah pun mencapai octet stability. So let's move to another fluorine terminal. So here again, F ada 2 elektron. Perlukan lagi 6 untuk capai octet. Nak ambil daripada mana? Ambil daripada this remaining electrons. Okay, so by doing that, kita akan tambah 6 dots on this fluorine. So by doing this, 14 tolak dengan 6, kita masih ada baki sebanyak 8 electrons. So again, check stability for this fluorine. So we have 2, 4, 6, 8. So this fluorine sudah pun mencapai octet. And the last part will be this fluorine. Again, you will do the same process sebab they are identical. Tambah lagi 6 elektron on that fluorine. Okay, so by doing this, okay, daripada 8 elektron, dah pakai sebanyak 6 di sini. So kita ada baki sebanyak 2 electrons. Okay, wow. Kita ada baki. We have balance. We have remaining electrons. So what should you do with the remaining electrons? Now, let's focus more on step 5. Sekiranya awak masih ada remaining electrons after you distribute penuh pada terminal atom tadi, maka the remaining electrons you have to put on the central atom. So since we have remaining sebanyak 2 electrons, kita letak 2 elektron ini pada central atom. And lastly, you have to check to make sure that all atoms iaitu terminal dan juga central atom has achieved octet. So here, this fluorine dah mencapai 2, 4, 6, 8 octet. Okay, so these two pun should be sama lah sebab they are identical terminal atoms. And for this nitrogen central atom, it has 2, 4, 6, 8 electrons. So in this Lewis structure, all atoms has gained octet stability. So, bila 2 elektron tolak dengan 2 elektron yang telah dipakai di sini tadi. So now, kita ada no more electrons. Okay, so you have to make sure bila buat lukis Lewis structure, semua elektron mesti dimasukkan ke dalam Lewis structure ini. Okay, so by doing that, maka awak sudah pun berjaya melukis Lewis structure untuk certain covalent compound. Nak something yang lebih mencabar? Let's try drawing Lewis structure for carbon dioxide. So again, the first step, calculate total number of valence electrons. So for carbon, we have 4 valence electrons. Oxygen has 6 valence electrons, so seems ada 2 O dekat sini. So you have to times 2. So the total valence electrons will be 16 electrons. Next, draw skeletal structure for carbon dioxide. So again, as the previous concept, put less electronegative atom at center. Jadikan less electronegative atom sebagai central atom and more electronegative atom as terminal atom. So between C and O, which one is less electronegative? Yeah, the answer is carbon. So carbon will be at the center and oxygen will be at terminal. So this will be the skeletal structure or skeletal arrangement untuk carbon dioxide. Next, draw single bond to connect between central and terminal atoms. So here we have 2 oxygen, 2 terminal, 1 central. So kita akan gunakan 2 single lines to connect between these atoms. So by having these 2 lines, ini menunjukkan bahawa kita dah guna sebanyak 4 electrons. So 2 electrons for this bonding and another 2 electron for that bonding. So how many remaining electrons do we have? 16 total, tolak dengan 4 for the bonding. So we have sebanyak 12 remaining electrons. In step 4, distribute the remaining electrons at the terminal atom until all terminal atoms achieve octet. So from the previous calculation, kita ada sebanyak 12 remaining electrons. So for this oxygen, sudah pun mempunyai 2 elektron. So 2 nak mencapai octet, that is 8. So this oxygen needs another 6 elektron. So dari mana nak ambil 6 elektron itu? Kita akan ambil daripada these 12 remaining electrons. So by doing that, kita akan tambah sebanyak 6 dots on this oxygen. So from the calculation, 12 tolak 6 yang baru kita pakai sekarang ni. So kita akan masih ada baki sebanyak 6 electrons. So you may check the stability of the oxygen as well. So this O now has 2, 4, 6, 8. Oxygen sudah mencapai octet stability. And the next oxygen here, sama juga, sudah ada 2 elektron. Nak mencapai octet perlukan lagi 6. So nak ambil daripada mana? Ambil daripada these 6 remaining electrons here. So with that, you akan lukis 6 dots to represent 6 elektron yang kita ambil just now. So daripada 6 remaining tadi, tolak 6 yang kita baru pakai just now. So we have no more electrons left. So from there, check stability untuk this oxygen. So this O dah ada 2, 4, 6, 8. So this terminal O has achieved octet and the same for this oxygen as well. So do we have other remaining electrons? The answer is no. We have no more remaining electrons. So cuba awak check octet stability untuk setiap atom. So this O has achieved octet 2, 4, 6, 8. This O has achieved octet 2, 4, 6, 8. And for this carbon, it has 2, 4. Seems like this carbon or central atom has not yet achieved octet. So in this case, kita akan pergi kepada step yang ke-6, iaitu if central atom is not yet octet, move lone pair from terminal atoms to form multiple bond. Okay, sama ada double ataupun triple bond. So here, oxygen ada elektron dekat luar ni. So these electrons are called lone pairs electron. Okay, elektron yang tak terlibat dalam bonding. So apa yang kita boleh buat adalah kita akan share satu pasang from the first O dengan carbon, and we will share another lone pair from the next oxygen dengan carbon. So by doing this, sebenarnya kita menghasilkan additional bonding pada setiap CO bonding tersebut. And this bonding kita panggil sebagai double bond. So from here, you boleh check lagi sekali octet stability untuk setiap atom. So this O has achieved octet rule 2468. Okay, this carbon has OB octet rule as well 2468, and this O pun dah mencapai octet 2468. So apabila semua atom in this structure sudah mencapai octet, maka this is our Lewis structure for carbon dioxide. So make sure in any steps of your drawing, you have to check sama ada all atoms sudah mencapai octet ataupun belum. So this is our important determination sama ada you have produced a good Lewis structure ataupun belum. Okay, sudahi dengan checking octet stability of all atoms. These are the comparison between single, double and triple covalent bonds. So for single bond, two atoms share a pair of electrons. So for every two atoms here, they will share two electrons. A pair means two electrons. Setiap dua atom akan sharing sebanyak dua elektron. Okay, so we have first pair here, second pair and third pair over here. It is represented by a single dash between two connected atoms. So a single bond is made up of a sigma bond. So that single bond, kita boleh juga simboliskan dia dengan menggunakan simbol sigma. Satu single bond represent sigma bonding. And for double bond, two atoms share two pair of electrons. Okay, in double bond, two atoms are sharing two pairs of electron. So dua elektron di atas dan dua elektron di bawah. Okay, so dua pasang lah. Okay, satu pasang consists of two electrons. So two atoms for double bond akan share sebanyak two pairs of electrons. Okay, iaitu mengandungi sebanyak 4 elektron. And it is represented by double dash, okay, between the two connected atoms. Double dash here, okay, to show that it is a double bond. And a double bond consists of one sigma bond and one pi bond. Okay, so dalam double bond ini mengandungi apa? Mengandungi satu sigma dan juga satu pi. Okay, satu double bond interaction mengandungi satu sigma bond and satu pi bond. So if we have another double bond di sini, so you can label the same thing, iaitu kita ada satu sigma bond dan juga satu pi bonding. And for the triple bond, two atoms are sharing three pairs of electrons. So in this example of nitrogen molecule, so two atoms here are sharing three pairs of electrons. So ada berapa banyak elektron pada triple bond ini? Kita ada sebanyak 3 pair. 3 pair bersamaan dengan 6 electrons. And it is represented by triple dash over here that connect between these two atoms. And a triple bond is made up of one sigma bond and two pi bonds. So this triple bond ini mengandungi apa? Mengandungi satu sigma dan 2 pi bonding. So these are the comparisons untuk double, single and triple bonds. Here are the comparison of the bond length and bond strength between single, double and triple bonds. So for the bond length, it is measured between two nuclei of atoms. So the distance between these two nuclei, kita akan dapat cari bond length of certain molecule. So according to bond length, the carbon-carbon single bond is the longest than the double and triple bond. So from this arrangement, kita boleh nampak bahawa carbon-carbon triple bond is the shortest between these three, and carbon-carbon single bond is the longest. And for the bond strength pula, okay, this arrangement is the reverse of the bond length. According to the bond strength, carbon-carbon single bond has the weakest. Meanwhile, carbon-carbon triple bond is the strongest. So arrangement of the strength is the vice versa of the length. Is the reverse of the bond length. So the shorter the bond length, the stronger the chemical bonding.